Hi everyone, welcome to Gnan Cloud Garage. In this session, I'm going to talk about Red Hat Enterprise Linux Core Operating System. In other words, we call it as RHEL Core OS or RHCOS. Any terminology we can use. Okay, here is the quick agenda. What is Red Hat Enterprise Linux Core OS? First, we can understand the definition of RHEL Core OS, and then what are all the RHEL Core OS features, benefits, and finally RHEL Core OS use cases. And before jumping to the definition of RHEL Core OS, let's quickly recap. Red Hat is a open hybrid cloud platform. We are aware. Even in our previous sessions, I talk about the Red Hat OpenShift container platform. It is a enterprise grade Kubernetes platform. As we are aware, if you have a OpenShift planning to install in our customer environment, we have a three types of options available. One is Red Hat OpenShift Kubernetes engine, that is comes with only the Kubernetes service, base OS and Kubernetes. And when it comes to the Red Hat OpenShift container platform, it comes with some additional features like platform services, application services, data services, and developer services. When it comes to the advanced edition, which is Red Hat and OpenShift Platform Plus, that means license also same name, Red Hat OPP. If you have OPP OpenShift Platform Plus license, it will allows you to utilize the Red Hat OpenShift advanced features, which includes ACM. ACM means Advanced Cluster Management, ACS, Advanced Cluster Security for Kubernetes, and Global Registry, which is QA, and cluster data management, that is OpenShift Data Foundation. That means in short form, Red Hat OpenShift ODF. Okay, but in this session, I'm going to focus on RHEL Core OS. So if you see within this our platform, in order to run our Linux container host operating system, we can utilize either Red Hat Enterprise Linux OS or we can use Red Hat Enterprise Linux Core OS. Either any one Linux container operating system we can use to run our Red Hat OpenShift platform. But for OpenShift, where we can run, we have a multiple options. We can run Red Hat OpenShift on physical, that means bare metal servers or physical servers, or we can run it on your virtual environment. One example is if you have a VMware vSphere platform, you can run the within our VMware virtual machines, we can install the Red Hat OpenShift container platform. And we can run it on private cloud environment, public cloud environment, and similarly edge locations. Okay. Generally, most of the telco customers, they require a OpenShift container platform must be run on their all edge locations. Okay. Now, let's talk about the Red Hat Enterprise Linux Core OS now. So RHEL Core OS, part of the Red Hat ecosystem, is a container optimized open source operating system designed for cloud native and containerized environments. Generally, Core OS is a containerized operating system developed by Core OS Corporation in earlier. Later, Core OS was acquired by Red Hat and forming the RHEL Core OS product. And this is specifically for a container environment. That means we can utilize only within a Red Hat OpenShift. That means enterprise grade Kubernetes platform. And this Core OS is a lightweight operating system. That means it will helpful for us to minimize cost, minimize effort. That means maintenance is very less maintenance compared to Red Hat Enterprise Linux general purpose operating system, and minimize risks. That means from the security perspective also, it's a highly secured operating system. Okay. And in addition, Red Hat Core operating system is the abstraction layer of between hardware. Hardware means we can run it on a bare metal or you can run it on a cloud environment. Bare metal means we can say hardware. Cloud means it can be a private cloud, hybrid cloud, or multi-cloud environments. Any cloud premises also we can run a Red Hat Core OS. So that's the reason we mention as it's the abstraction layer between hardware, and the container scheduling infrastructure. We have a multiple containers. So CoreOS is between the container environment and hardware layer. This is abstraction, okay? And it will also allows you to scheduling the infrastructure. So that means container runtime, master node infrastructure. Red Hat recommend that we have to install OpenShift container platform. Generally, OpenShift container platform, it comes with three master node, three worker nodes. Master node, we can also call it as control plane nodes. Within the control plane node, Red Hat recommends to run core operating system. When it comes to worker node, we have a flexibility. Either you can run RHEL, Red Hat Enterprise Linux OS, or you can run RHEL Core OS. That is the options Red Hat is providing. But recommendation is both master and workers, we can run Core OS, but there is a flexibility in our worker node. If you want to run RHEL also, we can run. Even as we see in our first diagram, Red Hat Open Hybrid Cloud Platform, they are open for any OS. Either you can use RHEL or you can use RHEL Core OS. But general recommendation is Red Hat Enterprise Linux Core OS. Reason is it's a lightweight and it will helpful to do our, it will be maintain easy administration as well. Maintenance also less maintenance and we less risk. Okay. Now there are some additional features within the RHEL Core OS. We'll talk about the additional features. See, Core OS focusing on the cluster. Here cluster means OpenShift cluster, OpenShift container platform. Generally, OpenShift container platform means it's a Kubernetes enterprise grade Kubernetes cluster. Okay, is only meant to be used with OpenShift. Okay, is a component of OpenShift. Correct. Why they mention component of OpenShift is when we are planning to run OpenShift container platform, this is by default, it's converged with operating system. That OS is Enterprise Linux Core OS. And wherever you run the OpenShift platform, either it can be hardware or it can be on private cloud, public cloud, or edge location. Any location, it's common. So that's the reason they mention RHEL Core OS is a component of OpenShift. Cluster and operating systems are versioned together. Versioned together means, suppose if I'm this Core OS introduced from the OpenShift 4 edition onwards. Now at present today we have the latest version Red Hat Enterprise Linux 4.13.13 edition. Okay, even let me show you in our lab system. We'll see the what is the current version we are running. I'm using the lab trial edition. If you see here, OpenShift, log into Red Hat OpenShift, we can see it is running on vSphere platform. OpenShift version is 4.13.13. But this core version introduced from version 4 onwards. What the point they are mentioning here is should be cluster and operating system versioned together. That means, let's say we have Enterprise Linux Core OS version is 4.0. That means OpenShift also will maintain the same version. Suppose Core OS version is 4.13, even our container platform version also 4.13. Okay. And where we can see the Core OS is, as I mentioned, OpenShift container platform comes with a 3 master node, 3 worker node. Suppose let me log into our lab system. Within the OpenShift web console, under the administration tab, go to the compute section. Under compute section, select nodes. You can see 3 master, 3 workers. The roles you can see control plane or master. Both are same. Control plane master. That means 3 master, 3 worker node. If you want to see the core OS, just select any one node. Under the details tab, you can see it is a Red Hat Enterprise Linux core operating system. Okay, so this is how we can validate the Red Hat Core OS. And similarly, just go back to nodes. Even if you want to test the any one worker, even worker, go to the details tab. You can see even this worker also running with the Red Hat Enterprise Linux core operating system. Okay. Now back to the slide. Should be managed through the cluster. So how we are managing is we are managing through OpenShift cluster only. Okay. This first cluster, we call it as a local cluster. And now reports when directly reports when directly accessed. Yes, from the OpenShift console, we can directly access and ties the container runtime to the version of Kubernetes. Even this is tied to the our Kubernetes versions as well. Even Kubernetes version, you can see from the same wizard worker node, you can see kubelet versions. Okay, kubeproxy versions. Current kubelet version is version 1.26. Okay, and same way in our master nodes also. Suppose if I select the master node, go to the details tab, we can see kubelet version 1.6. The same point ties the container runtime to the version of Kubernetes. And if you see the right side diagram, how we can bear physical or bare metal environment, how we can keep it in our rack. Let's say, as I mentioned, OpenShift, minimally we need 3 master, 3 worker node. In our lab, we are running on a vSphere platform, but in the production environment, it's recommended based on the customer choice. If it is a high sensitive applications, we may recommend to go with the bare metal. Some scenarios, we may recommend to go with the virtual environment. It's a subjected to application requirement or customer's choice. If you see in the diagram, let's say there are 3 nodes. That is a one node, 1 unit, 3 master nodes, and worker node generally it comes with a high configuration. That's why it's a 2 unit node, 1 2 3. So 3 masters, 3 worker nodes. Red Hat OpenShift Container Platform 4.x. That means any version. Current latest version is 4.13, and cluster with Red Hat OpenShift Data Foundation internal mode also available. Even ODF internal mode, in our previous class I explained you how to configure ODF internal mode. Okay, and optional option is we can also configure Red Hat OpenShift external mode. For external mode, minimally we need a 6 nodes. Let's say here, if you see 1 2 3 4 5 6, 6 nodes are required for a external mode storage configuration. Okay, this is for additional storage access to our worker nodes. Even initially we start with the 3 worker nodes. Suppose in the future, if your load is high on the workers, we can keep adding our worker nodes within our data center rack. And to communicate between all these master and worker nodes, we need a switches. CHP Aruba 8325 switches. 2 switches are available. Top rack switch, top of the rack switch. And for the management, for all the nodes, we need a management switch as well. For management, we are using HP Aruba 6300M. And storage, we are covering with a OpenShift Data Foundation internal. And if you need additional storage, we have a ODF external as well. Okay, and external benefit is it can be shared to not only one cluster, it can be shared to multiple OpenShift clusters. That is a benefit of ODF external. ODF internal means it's only dedicated for within a cluster. It cannot be shared to another OpenShift cluster. Okay. Now, another key point within the CoreOS is RHEL CoreOS is built for Kubernetes. Here, Kubernetes means enterprise grade Kubernetes. In other words, we call it as OCP, OpenShift Container Platform. So the features, what the features we included within the CoreOS is distributed as an OS image. Even we observed within our lab, it is running as a OS image, operating system image. And even we can download CoreOS from the Red Hat website individually. And transactional updates, okay, and all process outside the OS run as containers, and over the air automated updates, and machine config domain, and Ignition based metal and cloud host config. Metal means directly you can run it on physical server or bare metal servers, and we can run it on a cloud environments, any of the either private cloud or public cloud. Now, another point is the Red Hat CoreOS is deciding on philosophy. How they decided is minimal. It's a lightweight operating system in terms of providing packages. It won't give you more packages like our traditional Red Hat Enterprise Linux. It's a minimum lightweight operating system, so packages are very minimal. And immutable, controlled mutability. Immutable is nothing but a cannot be modified or cannot be edited. Effortless management. SSH usage is not required within a Red Hat CoreOS. And opinionated means support specific tools and use cases. and focus on the cluster. That means embedded OpenShift packages push management to the cluster. Now, let's talk about the immutable operating system. CoreOS, we also call it as a immutable operating system. So immutable operating system means, as I mentioned, it's a cannot be modified or cannot be edited. So CoreOS is versioned with OpenShift CoreOS, is tested and shipped in conjunction with the platform, and Red Hat runs thousands of tests against these configurations. CoreOS is managed by the OpenShift platform cluster, and operating system is operated as part of the cluster with the config for components managed by machine config. And operators, generally it includes the operators CRI-O config and kubectl, kubelet config, and we have authorized registries. Our registry is nothing but here we can use Red Hat Quay and SSH config. And RHEL Core OS admins are responsible for nothing. Okay, it's a lightweight, so nothing to do any administrative task on RHEL Core OS. Now let's talk about the RHEL Core OS security. So security wise, as I mentioned, it's a lightweight. Lightweight means definitely it's a highly secured operating system. Okay, and inherits security from RHEL Enterprise Linux, same kernel level support as RHEL, and SC Linux enforcing CVE updates directly from RHEL. And immutable is securable. Immutable means cannot edit. So it's completely unable to modify. Minimal configuration equal to minimal configuration drift. So fully converged via cluster, no SSH, config management vectors, and enable security via OpenShift. So one-click orchestrated rolling updates or upgrades reduces ops overhead. That means operational maintenance task time is reduced. And future work SSH access taints nodes as unschedulable and automatically alert or quarantine vulnerable nodes. Okay, so definitely during the vulnerability scan, there is a minimal security risk compared to traditional RHEL operating system, because Core OS is completely lightweight OS only. Even if you compare the operating system sizes also, generally Red Hat Enterprise Linux operating system, when you download ISO full bundle from the Red Hat website, it's approximately 9 GB size. But when it comes to Core OS, it's approximately around 1 GB size. So 9 GB, 1 GB means you can understand the size of the Core OS. It's only 1 GB, but RHEL traditionally is around 9 GB. Okay. Now, let's talk about the RHEL Core OS benefits. So the benefit, just now we noticed the feature is immutable. That means unable to edit or unable to modify the infrastructure. So within our container platform, we have OpenShift. It's combined with Enterprise Linux Core OS. It can be run on any environment, bare metal, virtual, private cloud, public cloud, or edge locations. So now, immutable infrastructure means Core OS follows an immutable update model. That means ensuring that the entire OS is replaced as a whole during updates. So this enhances the system consistency and predictability. Another benefit is container ready. That means optimized for running containerized applications using Docker and Kubernetes. Some scenarios Red Hat uses Docker, some scenarios it use Podman. Podman also similar as a Docker only. And Kubernetes. Red Hat Core OS provides an ideal platform for container orchestration. Container orchestration means it is nothing but our OpenShift. And another benefit is automated updates. So these automated updates and patches reduces the burden of manual maintenance and improves system security. And another benefit, security and hardening. So Core OS includes security features such as SE Linux and automatic updates, and also making it a secure choice for container workloads. And last but not the least, resource efficiency. That means, as I mentioned, resource efficiency means Core OS is a lightweight operating system. That means it's minimal footprint minimizes resource consumption and making it efficient for container deployment in resource constrained environments. Okay, now let's talk about the Red Hat Core OS use cases. So even within the use cases, Kubernetes cluster means our OpenShift cluster only, because Kubernetes OpenShift also Kubernetes only, but only difference is OpenShift is a enterprise grade Kubernetes cluster. Okay, almost the concepts are same as open source Kubernetes, but here it is a enterprise grade product. So Red Hat renamed the name as a OpenShift, but in the backend it still uses the kubectl commands only. So Kubernetes cluster means Core OS is commonly used as the OS for nodes in Kubernetes cluster, ensuring a consistent and secure foundation for container orchestration. Another use case, containerized microservices. So containerized microservice means generally it's a this platform Core OS ideal for deploying microservices as containers, providing isolation and secure efficiency. Another use case, cloud native applications. So cloud native applications means RHEL Core OS is well suited for modern cloud native application that rely on containerization and container orchestration platform. And edge computing. So generally not only in our private public environment, it is also suitable for the edge locations because of its lightweight nature, so makes it suitable for edge computing environment, whereas resources may be limited. One example is nowadays some of the telco customers, any telco customer, they have a multiple remote locations. So remote location instead of production, they call it as a edge locations. So within the edge location, most of the telco industries, telco customers, they recommended to run their telco application, containerized applications on OpenShift container platform. Okay, even during that scenario, they will also utilize instead of traditional RHEL OS, they will recommend to use Core OS because of lightweight and maintenance, also less maintenance. Okay, and last but not the least, continuous integration and continuous development. So for CI CD, so for CI CD pipeline, it's a solid choice for CI CD pipelines and automation due to its predictability and update model. Okay, so this is the main high level use cases of RHEL core operating system. Now, one real-time scenario is if you see the actual solution layout within a bare metal setup, Red Hat OpenShift container platform, we are using Enterprise Linux core operating system. As I mentioned, we need minimally 3 master node, 3 worker node. If you see here, we have a 3 master node and 3 worker nodes, and the models are HP DL385 Gen 10 Plus. If it is comes with the 5 means it's a AMD motherboard. Suppose 380 Gen 10 Plus means it's a motherboard comes with Intel model. Okay, and persistent volume options, we can use Red Hat OpenShift Data Foundation. So if we have a Data Foundation additional 6 server means this is a ODF external mode. In future, if you're going for a data fabric solution, we can use HPE Ezmeral. But underlying all our Red Hat OpenShift cluster using a enterprise Linux core OS. This is also one bare metal use case. Okay, hope you understand the importance of Red Hat Enterprise Linux core OS and core OS features, core OS benefits and use cases. Okay, that's it. Thank you. If you're watching this video first time, please do view, like, share, and subscribe to the Gnan Cloud Garage channel. If you're already subscribed, I appreciate all your support. Bye for now.